Hi everyone, hope you had a good week. Last week we covered the beginnings of what a script file was, and then we also talked about the for loop, a set of commands that you run one after the other as you count through numbers. And we'll revisit that today and talk also about some other flow control mechanisms like if and else statements before we work towards our new assignment. Let's get ready with Matlab. So, a second look at for statements. Let's create this variable. My name is Alejo. My name equals Alejo. So now we have here this string Alejo. What is a string? It's a list of 5 characters, A-L-E-J-O. And if we wanted to switch the case of my name, we know that adding 32 to it will get it to the right codes in the ASCII library. So how can we add those 32? This will remind you of your first assignment. So if we type help double, it will give us the double precision value for a character. A character isn't a double, so using the double command transforms it into its number equivalent. We saw this with the first assignment. We can say double my name, and we can get back the ASCII characters of those letters. So if we type in double of A, we get the number 97. If we type in double of capital A, we get 65. And we could subtract one from the other to find the difference, that should be 32. And we could assign one of those values to a variable, of course. And if we wanted to get the letter back, we can use the car command, as we saw. So if we want to type in back to A equals car of ASCII number of A, get back an A. And we can type in edit the car command. And you can see if you use one of the built-in functions in Matlab and you try to edit it, there's no code actually there, but they do have this help function written here so that if we were to type help car, that's what would show up here in the command window. Okay, so now that we have revisited turning those characters in a string to doubles and back, we can revisit this for loop. So this variable Alejo is just a list of 5 characters, so we could add 32 to each one in a loop. So we could make this new, let's make a new program called moo2. So we'll say edit moo2.m, and we want to create that. So here we are editing moo2, and we can take in this command from the command history and paste it in. And we'll say I equals 1 to start a counter for L equals my name. Low name I equals double L plus 32. I equals I plus 1. So now instead of counting through letters this way, we're counting the instances here of my name. Let's get L to type out every time we go through this loop so we can see what it's doing. So let's highlight this and press evaluate. So you can see L is equal to A, and then L, and then E, and then J, and then O. And each time L is equal to those things, you create the value that you want to represent it, and you add 32, and you add that to low name. So now low name becomes this new variable, a string of doubles that represents the letters. And then we can, as you know, get it back. And get back the lowercase version. And we can put that into our code here. Let's take out this L so we clean everything up, save it, and we can type in moo2 and get back this lowercase name Alejo. So the size of the name goes through indicates how many loops you do here of this function, because you do one for each letter in the name. And what if we use a capital A and then the lowercase Alejo? Let's put that in here. Save it, and we'll run it again. Now we have a problem where we've added 32 to a bunch of numbers and end up with symbols that represent those things, because these were lowercase. And as you remember, if we go on beyond the lowercase numbers, there's a bunch of funny symbols, which you can kind of see right here as well. And they don't even show up in the command window here. So what if we didn't want to do the for loop? You don't always have to do a for loop, and it's often slower. So you could edit your code to avoid that by doing something similar to what we did before. You could we can comment all this by pressing Control R or pressing comment here. And we might go ASCII name equals double my. Oh, and let's change this back to capitals. And then we'll say that the new name is equal to ASCII name plus 32. And the lowercase name is character of new name. And if we want to see if that's working, we could take the comment off. So we'll save it and we'll type in moo2 and we get the lowercase name. So now we've done this here without waiting to do each one in a loop. We've added to the whole function, just like when we solved our first homework assignment. So it's much faster to do this in this vector form than it is in a for loop where it has to count through each item. Let's create a function moo3. So we'll say edit moo3.m. And we want to create a new one. I'll turn off that pop-up. So in moo3, we want to add all the elements of a two-dimensional matrix that's entered by the user using input, a for loop, and the size command. We can say help size, and look here at size gives back an m by n matrix X, where the two-element row vector contains the number of rows and columns. So if someone were to enter test equals 3, 2, 3, 1, 2, 3, then we can say size of test should be 2 by 3. So we want to write this program that adds all the elements of a matrix together. So we might say for I equals 1 to the size we might start up here and say our new matrix is an input, enter a two-dimensional matrix. And then we get the matrix from the user, and we say S is equal to the size of that matrix. And now we have this variable S. And total will be where we save our values, and we'll start it at 0. So let's just run this part here and see what happens. Enter a two-dimensional matrix. 3, 2, 3, 1, 2, 3. So now, oh, we should also add clear all and CLC to our code so that we clear the workspace. And we'll say 3, 2, 3, 1, 2, 3. So we end up with this matrix. Size is the size of that matrix, and total is 0. So now we could say for I, counter equals to 1 until the first value of size, count through the number of rows. So let's change this I to an R. For C, columns is equal to 1 to the size of the number of columns, 3. Then we could say total is equal to total, what was there before, plus matrix RC. And let's actually take off this so we can see the output each time. And let's run through this and see if it sums up our matrix. So you can see it starts as 3, adds in 2, the next item, then adds in 3, the next item, then 1, 2, and 3, and the total becomes 14. And so let's comment, let's make that suppress its output now. And we'll head back to the slide here. So you should be able to work through on a piece of paper, or like I just did out loud, what happens on each of these loops. You go to a new row, you add each column. You go to the next row, you add each column. So you can make a bigger and bigger matrix and have the computer do this for you. So what if we instead were to go sum of matrix? Then we end up with the sum, but it's actually the sum only of each column, and we still end up with 3 values, 1 for each column. So we can go sum of matrix, and we can get that same value, 14. So one way to sum a matrix that doesn't use for loops is to double sum the matrix using the sum command. And so we could have also done that here, total equals sum of the matrix, and gotten the same number as this whole loop here. So let's save it and type in move3, enter a 2-dimensional matrix, 3, 2, 3, 1, 2, 3. And if we look at our output here, we got total. So we could even display total at the end of our code. And we get 14. So they can sum a matrix for people. Imagine what you could do with a gigantic matrix. Okay, I'll start this logic on the next video.